the time, or it will go at the same time?
These will never be, if you had, well, these two, or if you had 5, these valves will never open at the same time.
That's what I say. So that is what this one is for, like what I saw in the H2O plus the ammonium oxide operation here.
Yeah, even you can't even have that valve and this valve open at the same time.
Oh, okay.
It won't allow it, because then you'd have a CVD reaction.
1, 2, 1, 2, yeah.
Interlocks prevent that.
Yeah.
You can only have one AOD of valve open at any given time.
So you're going A-B reactions, A-B, A-B, or AA?
Well, AA is no reaction. AA is more like almost what we would have done with the conditioning
Yeah.
of the amp fuel. But we have interlocks, software interlocks, some hardware interlocks that prevent valves from opening at the same time.
Yeah.
So you can't, it's just the system won't allow you to do that. Now this is just one manifold. You have 5 fingers coming in here, and you have 5 fingers coming out. On the bottom side, I don't know if you can see it. On these 3, there's just a spool piece that goes in between here. And if you were to add more valves, if you were to upgrade, we just take that spool piece out and put the valve in there. So these valves are a 3-way valve. You have an out, you have an in for the cross flow, and then you have it for the precursor coming up off the bottom. So that you could add more valves. This, all these lines in this heater here, if you were to take it off, and I can take some of it off here. Nice. Just give you an idea. You'll notice that there's aluminum cladding everywhere. So the heater jacket, you have aluminum everywhere underneath that'll cover the line. The reason that the aluminum is there is it creates an oven effect on the gas line, so you don't have any cold spots. If you don't have any cold spots on the gas lines, then you won't have any molecular condensation in the spot. So if you don't have adsorption and you don't have condensation, then you don't have a parasitic CVD reaction at points. So everything is wrapped with a heater and wrapped with aluminum blocks. Aluminum is a very good thermal conductor, so that's the reason why we use it.
So our valves will be safe.
Yeah, it's better performance. And you can actually here, you can see there's already a hole for where a valve can go. So they're already made for that. No machining would be required on materials for that. They're already ready to go. That is just a basic overview of the hardware. Your capacitance manometer is here.
That's for
That is what measures your pressure.
manometer.
So that's what gives you this reading right here. So whenever we were doing the rate of rise yesterday, we would zero all flows and off all valves, and we would drive this down to, it was coming out to like 6.
Yeah, can you repeat that question again? And why that for? You say it's for 6?
Well, it's lower now because it was pumping and heating overnight and running the process. This is fairly well conditioned. This reading here is all coming off this cap.
Manometer.
So every once in a while, that will need to be calibrated, and you want to have it down to a small number. You don't want to have it totally zero. You want to have like 0.001. And how you adjust that is through this. There's a small potentiometer right here. Very, very small flathead screwdriver. So every once in a while, maybe once a year,
Calibration.
Huh?
Calibration.
Yes.
That's like screw and
Yeah.
rotate it or something like that.
Yeah. Clockwise increases, counterclockwise. You don't want to bring it down to 0. You want like 0.001.
I think I saw it bruised.
You are on the run recipe.
Yeah, I just gave it some gas. Some gas flow. So, let's talk about software. This is, well, you've seen where to log in. This is the vacuum screen right here. The vacuum screen and the other screens, you can see some information that hasn't been acknowledged. Up here, you can acknowledge it, which will clear it out, but you could also, if there was a problem or you wanted to look for more information, anything that's already on here, you can come into messages and you could pull down a little bit more information. So, for example, yesterday, whenever we ran the process recipe right here, this says it was completed. If we wanted to know when it was completed, we can come into the messages and we can scroll up. Right here. So now we have a little bit more information. It says a little after 7, it stopped. So that's the messages. Screenshot works just like any other screenshot, but if you're trying to screenshot a pop-up window, if there was a problem, you have a pop-up window, then you have to do control print screen. You can't just do a screenshot from here. The host comms, this is just LEDs that's coming off your real-time controller, so you have normal operation here. This essentially works like a light bar. So if there was an interlock present, you'll get here, but that condition might have gone away. Now if we hit acknowledge, that'll clear. Green, everything's good. If you're running a recipe, you'll hit blue. If this recipe's paused, you'll see a blue flickering. Interlock will be yellow, or if there was an abort, it'll be red. Once the condition clears and you hit acknowledge, then it'll come back to green.
So, for example, in this case, do you determine the fellow set point, or so is already set by the system automatically?
Which set point?
Fellow set point here, 120.
Oh, that's in a recipe.
Based on the recipe.
We're trying to make all the recipes
Yeah.
and the processes as close as like hitting a popcorn button on a microwave. The process recipe is separate. Heating recipes are separate. They're not together. So you have the heating recipe and a process recipe
So
and the
even
gas recipe.
even the pressure 0.6 millitorr is based on the recipe should be set, or always for all the deposition process, this is the pressure for vacuum we need to get.
I think I want to answer it. So this is an input because it's green. It's an analog input. It's a condition. It's not a set point. The white is a set point.
I understand. These are input. This is not input, but so this is the value for all the recipe we expect to see before conducting the deposition process.
Yeah, you'll have a little bit of variance. It won't be always the same because
0.6.
if you put a dirty sample in, it'll be outgassing for a little bit, so your pressure will be a little bit higher.
Yeah.
It should be roughly the same. So this value is more dependent upon like the AOD IGF recipe. This is the recipe that runs the gas flow, the argon gas flow for your process. That sets the gas flow here, and it also sets your gas flow here. So the sum of that is what's giving you this reading. If that were to change, let's hit 20 here. Now you see the effect
Oh, so we can say that a strong function of this one.
here. Yes,
Oh, yeah.
it's directly proportional.
Yeah, directly proportional.
But if you have put a dirty sample in, then maybe it's outgassing. So maybe your pressure will be a little bit different.
Yes, I got it.
Generally speaking, you'll be around 600 millitorr whenever you're doing
Yeah,
your process.
0.6, yeah, I got it.
Sometimes, if
It's
you
0.6 millitorr.
600 millitorr, 0.6 torque.
0.6 torque.
Yeah, this is in torque.
Yes.
For TMA, hafnium oxide, zirconium oxide, this pressure will work fine. You may find yourself in years to come that you might use a precursor that has a very low vapor pressure. Maybe the vapor pressure is about 150 or 200 millitorr. So if the vapor pressure is very low pressure and your reactor is at a higher pressure, you'll never get anything out. So that would be a condition where, okay, we would change the inert gas flow factor to bring it down to a good process recipe to get that out, that particular material out, depending on the vapor pressure of the material. TMA has a high vapor pressure. It's greater than 1, so you don't have to heat it. The hafnium or zirconium, if you heat it, you can still run this gas flow, you'll be fine. But there are other precursors that you cannot run at this pressure. You have to have a lower pressure. I don't foresee you using any of those in the next 2 years. Coming around here, screenshot. Abort system, I want an abort system. That's like a catch-all for everything. The recipes have an abort process recipe already built into it.
How even the recipe should be revisited. Then you abort.
It's already been incorporated. Whenever I get into the recipes, I'll explain that a little bit further. On the vacuum screen, you have run recipe, recipe editor, recording setup, PC pump, PC vent. You can control what's seen on here through different editing screens. On a run recipe, you have a small pull down. In the recipe category, you can select what will be seen on here and what won't be. So this is just a quick start. Recipe editor, I'll cover that whenever we get into the recipes. Recording setup. The recording setup, a lot of this is explained in pretty good detail in these books here. So in the operation manual, you have manual operation, recipes. This is not specific to this tool. It gives general examples. So I would recommend, especially in a manual operation and the recipes, kind of like skimming through it so you know what's there. You don't have to memorize it by any means, but you can use it as a reference. So that's 2 tabs in this binder that I would definitely look at. This other binder, this is individual manuals
should not be. Oh, must be a combination. So you have a binder for the individual components, the hardware components, the whatever the manufacturer's manual. So that's in this binder. You should have, this is for the Nano 36. You should have one more for ALD, LE. Same tabs, different manual.
Sir, let me ask you a conceptual question. You may answer it yesterday earlier. My question is that in the catalog of the device and advertisement, I'm seeing that they emphasize on the keyboard that is control surface film growth. Which distinguishes this ALD system from the other deposition system, this feature. Control surface film growth. What does that mean exactly?
For continuous film growth?
Yeah, control surface film growth or control surface deposition.
Contour.
Not control.
Control.
Yeah, control surface deposition or film growth.
I'd have to see what the context it was used in. I'd have to see how it was written.
Yeah. I'll show you
Yeah, if
later.
I see how it's written, I
I have it
can
on
explain it a
the
little bit
desktop.
better.
I save it. Yeah, thank you.
So that manual will be around. That's the Nano. That's this one here. Okay. Same thing here. This has the individual components like the Catman and the pump and stuff like that. This has operation,